40 years ago, a single research plot was planted in a quiet corner of Pennsylvania, and what has grown there since then quietly contradicts almost everything modern American agriculture believes about feeding a country. Same corn variety on every plot, same weather, same starting soil. The only thing that changed was how the dirt got treated. And 4 decades later, when a drought hit hard enough to dry up most of the cornfields in the county, one set of plots kept standing while the rest collapsed. Same seed, same rain, same 9 inches across 3 months. 31% more grain in the bin at harvest time. And the reason has almost nothing to do with what most modern gardeners think keeps a crop alive in a dry summer. That is not a number from a brochure. It is 40 years of side-by-side, peer-reviewed data gathered by an institute documenting exactly what happens when soil is treated the way Amish farmers have been treating it for almost 300 years. Quietly, without fanfare, using methods the rest of American agriculture decided were outdated about 100 years ago and have been working hard to forget ever since. The reason that corn lived was not magic. It was not luck. It was something done to the soil decades earlier, slowly, season by season, by hands that knew what they were doing long before any university got around to writing it up. And the same kind of soil can be built in a backyard, with no special equipment and almost no money. The catch is that nobody selling fertilizer is in a hurry to mention it. So why is a method this powerful not being taught in every county extension office? The answer is something older and quieter than a conspiracy. The synthetic fertilizer industry pulls in over $230 billion in revenue every year. The chemistry goes back to a German laboratory in 1908 when 2 chemists named Fritz Haber and Karl Bosch figured out how to pull nitrogen out of thin air and turn it into ammonia. That single invention is credited with feeding half the people alive today. Without it, the modern world would look very different. The story being told here is not anti-science. It is something more specific than that. Every powerful tool carries a hidden cost. The cost of synthetic nitrogen reveals itself slowly, underground, in places almost nobody looks. Season after season, the concentrated mineral salts hit the soil, and the microscopic life that holds the ground together starts to die off. The bacteria collapse. The fungal networks come apart. The soil itself loses the one thing soil is supposed to do, which is soak up rain, hold it, and feed it back out to thirsty roots in August when nothing has fallen from the sky in weeks. The ground gets harder, the next drought gets worse, and the only fix anyone is selling is more product next spring. That is not a conspiracy. That is just how the business has to work. There is no money in a soil that takes care of itself. In 1981, a man named Robert Rodale set out to test something his father had been arguing for 40 years already. The whole idea fits in one sentence. Healthy soil makes healthy food makes healthy people. He laid out 12 acres of land just outside Kutztown, Pennsylvania, divided into 72 plots. 3 farming systems compared side by side. Conventional synthetic on one set, organic with legume cover crops on a second, organic built around composted livestock manure on the third. Same crops, same weather, same starting soil. The only thing that varied was how the dirt got treated over time. 40 years later, the results are not subtle. In normal years, all 3 systems produce about the same. That alone is worth pausing on for a second because the whole sales pitch for synthetic fertilizer rests on the idea that without it, harvests collapse. In normal weather, that is not true. In drought years, the gap opens up wide. According to the Farming Systems Trial 40-year report published in 2021, 15 to 20% more water actually moves down into organic soil than into chemical soil. The water gets in faster, it stays longer. The organic matter, the dark crumbly stuff that gives healthy ground its smell and its sponge feel in the hand, keeps climbing in the organic plots and stays essentially flat in the conventional ones. The mechanism, when it is written out, is almost embarrassingly simple. Any gardener old enough to have learned from a grandmother already knows it without ever needing to read it on a page. Soil that is alive holds water. Soil that has been chemically stripped does not. The science of why turned out to be one of the strangest little discoveries in modern agriculture. In 1996, a soil scientist named Sarah Wright at the USDA Agricultural Research Service in Beltsville, Maryland, was looking at mycorrhizal fungi under the microscope. Those are the thread-like organisms that live in partnership with plant roots, the same ones that have been quietly running soil for 400 million years. And she noticed something nobody had described before. A sticky, glue-like substance coating the fungal filaments and binding to soil particles all around them. She named it glomalin. Glomalin is the biological adhesive that binds tiny soil particles into stable clumps. Those clumps are what give healthy soil that sponge feel in the hand. The texture that lets rain soak in instead of running off. The structure that holds moisture for weeks after a storm passes. It is the reason an old farm field smells the way it does after a rain. That smell has a name, petrichor. And in a real sense, it is the smell of glomalin doing its work underground. Roughly 27% of all the carbon in the world's soils is held inside glomalin, more than any other single compound, and it is produced only by mycorrhizal fungi, the kind that need undisturbed ground with living roots. Tilling destroys glomalin. Synthetic fertilizer suppresses the fungi that make it. Bare fields between crops starve them. Every standard practice of modern conventional agriculture, the rototiller in spring, the bag of nitrogen in summer, the empty stubble through fall and winter, quietly takes apart the very system that protects soil from drought. And every standard Amish practice, almost by accident, protects it. The Amish do not farm the way they do because somebody handed them a soil science paper. They farm that way because that is the way it has been done in their families since Jacob Ammann led the split from the Swiss Mennonites in 1693. Since the ship Charming Nancy docked in Philadelphia on the 8th of October, 1737, carrying the first significant group of Amish families to North America. The practices are old. The science explaining them is brand new. 5 things define the method. The first is rotation with legumes. Alfalfa, red clover, white clover, hairy vetch. These plants partner with bacteria called rhizobia that pull nitrogen straight out of the air and tuck it into nodules along the roots. A mature alfalfa stand can supply somewhere between 128 and 250 pounds of nitrogen per acre per year. The corn planted in the same ground the following spring often needs no added nitrogen at all. The field, in plain English, fertilizes itself. The second is composted livestock manure. Slow release, microbially alive, building soil organic matter year after year. Research published in Frontiers in Microbiology in 2017 showed that adding manure alongside conventional fertilizer raised soil organic carbon by between 54 and 143% compared to fertilizer alone. The third is minimal tillage. Horse-drawn implements simply do not penetrate or churn the soil the way a heavy tractor with a deep plow does. The fungal networks survive. The glomalin survives. The structure built last year stays intact instead of getting torn apart every April. The fourth is cover crops, cereal rye, hairy vetch, buckwheat. Living roots in the soil through every season, feeding the microbes underneath even when no cash crop is growing above. And the fifth is mixed crop livestock farming. The animals eat from the land, fertilize the land, and the cycle closes on itself. No bag, no truck, no purchase order, just biology doing what biology has done since farming began. Worth saying plainly here because there is a romantic story that needs correcting before it gets any taller than it already is. Not every Amish farmer farms organically. Some use synthetic inputs. And in many communities today, fewer than half of families are still farming at all, pushed out by land prices that in Lancaster County now reach $30,000 an acre and climbing. The method described here is the traditional one, the one that built the legendary soils of southeastern Pennsylvania. It is not universally practiced anymore, even by the community that perfected it, which is exactly why the Rodale data matters. It takes the method out of the hands of the people and tests what the method alone can do on a controlled plot, under controlled conditions, year after year for 4 decades. 2016 was the year that settled the question. Berks County got 9 inches of rain across 3 months. The conventional plots at the farming systems trial suffered the way most cornfields in the region suffered. The organic manure plots, the ones built up over 35 years of compost and rotation and minimal tillage, kept producing. And here is the part that overturns the modern gardener's basic instinct. Nothing was added during the drought, nothing at all. The drought-proofing had been done decades earlier, slowly, season by season, in the form of organic matter accumulating underground while nobody was watching. The fix for next summer's drought is not something to buy next summer. It is something to start building this year. The principles compress beautifully into a backyard garden bed, and they cost almost nothing. Stop tilling. For an established bed, the rototiller and the shovel can mostly go away. Every spring, tillage tears apart the fungal network the soil spent the previous year rebuilding. Top dress instead. Spread compost on the surface and let the earthworms pull it down, the way the forest floor has been doing it for 100 million years without anyone supervising. Compost everything. Kitchen scraps, fallen leaves, grass clippings, aged manure when there is access to it. Small amounts spread regularly do more good than big piles dumped once. Cover the soil through winter. A simple scattering of cereal rye in October will hold the ground together until April, suppress weeds, and feed the microbes. $5 of seed in the fall replaces months of weeding in the spring. Rotate, even in a small garden. Tomatoes in one bed this year, beans in that bed next year, brassicas the year after. 3 rotations and the soil starts to remember what diversity feels like. A backyard cannot match a 40-year research plot in a single season. Year 1 will look ordinary. Year 3 is when most gardeners start noticing. The way the soil holds water through an August heat wave, the way it crumbles in the hand instead of cracking like a sidewalk. The way the earthworms come back without being invited. It used to be the kind of thing grandfathers said about their grandfathers. The good ground takes time, and once it is built, it does not unbuild itself. David Kline, the Amish farmer the writer Wes Jackson once called the Amish Thoreau, asked a question in his 1990 book Great Possessions that has not lost any of its weight. He asked whether it makes sense to give up a kind of farming proven to preserve communities and land, and ecologically and spiritually sound, in exchange for one that is culturally and environmentally harmful. That is a question worth sitting with, because the methods being described here are not new. They are not innovations. They are the practices that built the soil under most of America before 1908, before nitrogen came out of a factory, before bags replaced barns. They were lost almost everywhere and kept alive in a few stubborn corners by a people who never asked permission to keep them. The 40-year research plot at Kutztown is just modern science finally catching up to what the buggies down the road already knew. The soil they built will outlast everything else they made. The fences will fall. The barns will sag. The names on the mailboxes will change. The dark, crumbling earth underneath, the living soil that holds the rain and feeds the roots and survives the droughts, that soil will still be there generations from now, doing what it was built to do. A grandchild digging in it 20 years from today will not know why the tomatoes taste the way the ones in the old photograph used to taste. But the soil will know. The soil always knows. If this struck a chord, leave a comment below with what is growing in the garden right now and what the soil there has been through. Share this video with someone who might be ready to put the rototiller away for good. Hit the like button so more people find this story, and subscribe to Forgotten Soil Wisdom for more of the old ground being rediscovered. Until next time.